In the first part of this example, we're dealing with a car that has to stop very quickly. Its initial velocity is 20.0 meters per second. The driver slams on the brakes, and the brakes provide an acceleration of negative 2.1 meters per second squared. Now remember, the acceleration is negative because it opposes the velocity. If the velocity is positive, then the acceleration must be negative. The final velocity, of course, is 0 because we want the car to stop. And the question is, what's the displacement? Well, we can relate velocity, acceleration, and displacement through equation 215. V squared equals V naught squared plus 2a delta x. We were given V, it's 0. We were also given V naught, it's 20.0 meters per second. We're also given the acceleration, negative 2.1 meters per second squared. The only thing we don't know is the displacement. So we now have an equation. All we have to do is solve for x. Let's subtract 20.0 meters per second quantity squared from both sides of the equation. If we do that, it disappears from the right-hand side of the equation and appears as a negative on the left-hand side of the equation. Alright, now we have to divide both sides by 2 times negative 2.1 meters per second squared. When we do that, it disappears on the right and appears in the denominator of the left-hand side of the equation. So now we have an equation for delta x. When I square 20.0, I get 4.00 times 10 to the 2. I'm writing it that way to emphasize we have 3 significant figures. When I multiply 2 by negative 2.1, I get negative 4.2. So delta x is negative 4.00 times 10 to the 2 meters squared per second squared over negative 4.2 meters per second squared. Now look what happens to the units. The squared part of meters squared on the top of the fraction cancels with the meters on the bottom of the fraction. Also, second squared completely cancels out. So in the end, we're left with the unit meters, which is good because we're looking for displacement. When we divide out the numbers, we get 95. So the car traveled a total of 95 meters before it came to a stop. Now I'm not going to solve the second part of this example for you because it's pretty much just like this one. You're using the same equation. The only differences are you're solving for a instead of delta x. And also you have to make a unit conversion to make the units consistent. Other than that, it's just like this example.